Hi, I realized that I talked a lot about strategy. I didn't actually show you a solution. It's nice to look at a solution in Desmos. So I'm going to do the most direct solution that we talked about in the video. So I'm going to use, so you could think about it parametrically or you could think about it in terms of vectors, but I'm going to define a point on the circle that's a function of an angle. So for the x-coordinate, we've got 3 plus the radius times cosine of some angle. And then for the y value, p subscript y, we've got, 4 plus 2, the radius 2 times sine of that same angle. And you can see, if I plot them as a point with a slider for the angle, you can see that this generates a point on the circle as I drag my angle around. So now I'm going to go ahead and define the line. And the line is going to be in this form. Slope times x minus an x-coordinate I know is on my line, which is the same as the x-coordinates on the circle, plus a y-coordinates that's on my line. So now all I need to do is figure out what should the slope be. Right now the slope's just 1, and as you can see, as I move the point around, the slope isn't changing. So I need to calculate the m value as a function of the xy coordinates here. As I said before, I know that the slope of the tangent line is the negative reciprocal of that slope. So let's figure out what this slope is for any arbitrary point at px, py. So I know slope is change in y divided by change in x. So here the change in y is 2 times sine of the angle. And here the change in x is 2 times cosine of the angle. So if I want to do change in y divided by change in x, I'll just divide those two. The 2's divide each other to make 1, and I've just got sine over cosine, which is the same thing as tangent. Okay, so if I now want to find the slope of this other line, I take the opposite of tangent, and I take the reciprocal. So negative 1 over tangent, which is the same thing as negative cotangent. You don't have to use cotangent. I just put it here because it seemed convenient, and it's, it accurately describes what this is. But if you wanted to, you could perfectly well write this as negative cosine over sine. You wouldn't have even had to rewrite this sine over cosine as tangent. Just realize that when you find the negative reciprocal, that ratio is going to invert. So let's go ahead and plug that in now. So here I've got slope is going to be negative cotangent of my angle, which is undefined for that particular value. But now, as I drag my point around, you see a whole infinite family of solutions. And so now it's really easy for me to get any solution I want just by choosing an angle. And now I know how to calculate the slope, and I know how to calculate px and py. And if you were looking for what equation did we actually end up with here, I just wrote the general form, slope times x minus an x-coordinate plus a y-coordinate. But if you were going to substitute in all of the expressions that we calculated for these various parameters, you would end up getting y equals opposite cotangent a times x minus this thing plus that thing. And what you want to realize here is what's a number and what's a variable. That's the only variable. There it is, x. Well, you got the y, right? But this is the number that represents slope. This is the number that represents the x-coordinate, and this is the number that represents the y-coordinate. And each of these values depends on your parameter a. So it's if you choose some particular a value, you plug it in, and you get a number for your y-coordinate, a number for your x-coordinate, and a number for your slope. And those numbers all happen to work out so that the line that's described here is a tangent line. Okay, I hope that this was helpful. Enjoy your weekends.